sketching the graph of the parabolic function. Until now, we have drawn parabolas using a table of values and by plotting. We shall now use the characteristics of a parabola to draw a sketch graph. A sketch graph is a rough sketch of a function that gives its shape, the intercepts on the axes if they exist, and the turning point. Here, the sketch graph of y equals x squared is drawn. Observe that this parabola is open upwards, since the value of the parameter a is positive. We mark the intercepts and the turning point. For this parabola, the x-intercept, the y-intercept, and the turning point are the same, 0, 0. The sketch graph may also show other characteristics, like the axis of symmetry, domain, and range. Now, we shall see how to draw the sketch graph of any parabola y equals ax squared plus q. We require the following characteristics: the sign of the parameter a, the value of the y-intercept, the value of the x-intercepts, if they exist, the turning point of the parabola. Let us apply this to the parabola y equals 1 over 2x squared minus 2. Here, a is equal to 1 over 2, q is equal to negative 2. Since a is positive, the graph will be open upwards, but we don't know yet exactly where the parabola will intercept the axes and its turning point. Let us find those before we can sketch the graph. The turning point of a parabola of the form y equals ax squared plus q is the point 0, q. Here it is, 0, negative 2. We mark this on the sketch. The y-intercept is found by setting x is equal to 0 in the function. Y equals 1 over 2, 0 squared minus 2. Therefore, y is equal to negative 2. The point 0, negative 2, is the y-intercept, which is also the turning point. The x-intercept is found by setting y is equal to 0 in the function. 0 is equal to 1 over 2x squared minus 2. X squared is equal to 4. Therefore, x is equal to plus minus 2. There are two x-intercepts, minus 2, 0, and 2, 0. We now sketch the graph of the parabola passing through the two x-intercepts and the y-intercept. We can also mention the domain, range, and the axis of symmetry on the sketch. The parabola is symmetrical about the y-axis. Let us now sketch another parabola. Y is equal to negative x squared plus 16. Here, a is equal to negative 1, q is equal to 16. Since a is negative, the graph will open downwards. We now find the turning point and the intercepts that the parabola makes on the axes before we can sketch the graph. The turning point is 0, q. Therefore, 0, 16. We mark this on the sketch. The y-intercept is found by setting x is equal to 0 in the function. Y is equal to negative 1 times 0 squared plus 16. Therefore, y is equal to 16. The point 0, 16 is the y-intercept, which is also the turning point. The x-intercept is found by setting y is equal to 0 in the function. 0 is equal to negative x squared plus 16. X squared is equal to 16. Therefore, x is equal to plus minus 4. There are two x-intercepts, negative 4, 0, and 4, 0. We now sketch the graph of the parabola, passing through the two x-intercepts and the y-intercept. We again mention the domain, range, and the axis of symmetry on the sketch. The parabola is symmetrical about the y-axis.
Need more help? Subscribe to our channel. Can't wait that long? Ask Mesky to help you and let the math finally start mathing.